Okay, welcome back. This is the second PowerPoint in our week in this week's set of PowerPoints to do, because you're going to have to do the math in this part. So I will be available if you ever need to call me or talk to me about how to do some of this math, okay? So we're going to talk about signal scaling and how we're going to take the transmitter and we're going to read a sensing number, and then convert that to another number, which happens to be probably 4 to 20 milliamps, all right? So scaling, what is that exactly? So an instrument scale is the range of an ordered marks at fixed interval inscribed on an indicator plate. If you go out to a local field mount and you see a pressure gauge, you'll see 0 to maybe 30 psig, and that is broken down in intervals, right? And wherever the arrow is pointing, then that's telling you what the pressure is, and you have to calculate that out by breaking it down mathematically. So when you're calibrating a transmitter, you have a scale, the input scale and the output scale. We have done this with the DP cell that was doing level in our PC 101 trainer. We noticed that 0 inches of water was equal to 0 or 4 milliamps, and then we went, I think, to 8 inches on our scale, which would have been 100%, which were 20 milliamps. Sorry, so 0 was equal to 4 milliamps, and 8 inches at 100% was equal to 20. So that's just how you look at that. So scaling converts process signals so that it can be read by the instruments downstream and or your control systems. So calibrating, this is again applying a set of input values and measuring the component and then adjusting the output to make that range make sense. Okay. Now in chapter 15 there is much more detail about this. However, in this class we will not cover it, but ELC 270 will, and you can go, when you go to that class you can cover that, or you can even look ahead. So the act of equating a numerical value of one scale to its mathematically proportional value to another scale is what we'll be covering. Let's talk about the scaling terms. So let's just take this example. We have a pressure gauge. It reads 50 psig to 150, or it's a transmitter sensor. So our upper range would be this 150 psig. It's the top of the scale. It's a number. The lower range is the lower end. 50 psig. We didn't start at 0 here. We started at 50. That's the lower number of the scale, one number. The range is 50 to 150 psig. So that's two numbers. Now the span is you take the higher number and you subtract the lower number, and that gives you the span of that. So 150 minus 50 gives you 100. So the actual span that's covering is 100 psig. Now when we want to calculate the output of a transmitter, we're going to be going from one value to another. Okay, we only deal with linear scaling here, all right, and that's mostly what you'll be dealing with anyway. So the value B will be the new value, and value A is your original scale. So in the case of just say pressure, and we're going to transmit it pressure, and we're going to convert it to milliamps, which is basically what you'll be doing most of the time. Okay, you're going to start with your initial value in pressures and your span, and you're going to multiply by your span in milliamps and adding that lower range value, so 4 to 20. So this is pretty straightforward, and we'll see examples of that. Okay, let's take this example. Now, we have a transmitter. It's pressure. It goes from 0 psig to 50. That is my range, all right? My current value is 25 psig. We want to know what that converts to in milliamps. Our transmitter output will be from 4 milliamps to 20. That is our range. And then our span is 16 milliamps. So we'll talk about these numbers. So here's how you solve it. This is in page 184, and if you want to look at that there, if that helps you as well. The pressure transmitters are ranged from 0 to 50 psig. Its current process variable reading is 25 psig. What is its current coming out of the transmitter? We're going to solve for value B in milliamps. So value B is equal to value A. The current value is 25 psig, 25 here, minus the lower range value, which is 0. So 25 minus 0. We take that number and we divide it by the span. The span is 50 minus 0. It's 50, so that equals 1/2. Now we multiply that by the span of the new transmitter output scale, which happens to be milliamps. 20 minus 4 is the span, which is 16. We take this number, which is half, and multiply that by 16. Then we have to add where we start on that other scale, and we happen to start at 4. So it's 1/2 of 16, which is 8, plus 4 equals 12. So you can look at that and see that this is exactly halfway through, and I think we've done this before. 4 to 20, we know 12 milliamps is generally 50% of the scale, which is what 25 is, percent of the span as well. Okay, now let's just talk about a flow sensor and a transmitter. So let's just take this flow sensor. The sensor reads 0 GPM to 100 GPM. It converts in the transmitter, the reading on the transmitter will usually be in GPM, but then it sends the signals out in milliamps. So 0 GPM will be 4 milliamps. 100 GPM will be 20 milliamps. Let's take our pH sensor. Our pH on the low end reads 1 to 14. That's our range. We have 1 where it's acidic and 14 basic. 1 will read 4 milliamps. So everything below 7 in milliamps will correlate to an acidic type of substance. From 14 will be 20. That's our max. So anything above this 12 milliamps to 20 will read a basic type of substance. Okay. And then our temperature sensor and transmitter. Our temperature, we're going to start at 25 and we're going to go to 80. So this is our range. The low range value is 25, correlates to 4 milliamps. And then 80 correlates to the 20. So these are our two ways that we would do the calculations. Right, now let's try, first off, let's talk about the span, percent of span. This is the equation we did before. I mean, we hadn't done too many examples of it, but the percent of span. So it says, what is the percent of span, or how full, what is the percentage of the tank at 150 inches of water? Okay, so we like to know in percentages, right? It's just easier to correlate and make sense of things. So first we need to know what our range is. It's 0 to 200 inches of water. That can give us my span. So 200 minus 0 is 200. That's the span. My current value is 150. So I put 150 here minus my low range, starts at 0. So 150 minus 0 divided by the span, which is 200, and then I multiply by 100. That gives me 75%. Okay, so you will read 75% full. How much is it full at 78 inches of water? Again, what is the percent of span? The value is 78. 78 minus 0, and this again is 200. So the span is 200 minus 0 is 200. 78, the current value, 78 minus 0 divided by 200, which is the span, times 100 gives you 39%. So if you look at the span, right, it goes 0 to 200. So you would know what 100 should be 50% full, right? If it's lower than 100, which 78 is, you would expect this number to be lower than 50%, which it is. So you should check your math and make sure that it makes sense. Now, what percent full is the tank at 45 inches of water? What's our span? 0 to 100. So again, is it less than 50? 50 is halfway through, yeah, so it should be less than 50. Here, this is a straightforward one because their scale is 0 to 100, and we're going to be doing the multiplications in hundreds, so it works out really nicely. So our value is 45 minus our low range, which is 0 inches of water, all divided by our span. Our span is the upper range minus the lower range. 100 minus 0 is 100, and then we multiply by 100 to give us percent. That should equal 45%, and it makes sense. Again, if 50 would be half full, and we know this is lower. Okay, now we're going to talk about how we're going to take this number, which is reading 50 inches of water, okay, and convert that into an milliamp, okay? So let's go back again. So what is the output coming to the transmitter to go to the controller? You'll read this number on the transmitter, and it'll also convert and send to the controller what the actual output would be in milliamps. Let's do that. So this is the equation you need to know. Don't worry about memorizing it. It'll be, if you have it, again, on any test will be open book from now on. So just make sure you understand where to find it and if you understand it. Okay, so that's what's most important. So our new value, which we're going to get in milliamps, is equal to our original value, which is in inches of water. And we're going to take that, subtract the lower range value, divided by the original span, and then multiply by the new span. And then we're just going to add the 0 point of where this begins, okay? So let's look at that. What is the milliamperage output of a transmitter at 50 inches of water? Okay, so 50 is our value A. So 50 inches, value A, minus our low range, which is 0, divided by our span. Our span is 100 inches upper range minus 0 inches lower range. That equals 100. So 50 minus 0 divided by 100 times the new span, Well, the span is always in millivolts. 4 to 20 is always going to be 16. So you take these two numbers and multiply them, and then you add your 4, okay? So what do you get there? You should get 8 for that, all right? Let's just check it real quick. So we have 50 minus 0 divided by 100 times 16 is 8 plus 4 is 12. I think I said 8, but I meant 12. So again, that's halfway through. All right, so that makes sense. Let's try this one. We have 75 inches of water. Okay, so what do we start with? 75 inches minus 0, okay, divided by the range. Our range is different. It's 200, I'm sorry, the span. Yeah, our range is 0 to 100, 200. So our span is 200 minus 0, which is 200. And then we multiply that, but this stays the same because we're always in milliamps, times 60 milliamps plus 4, okay? That equals 10. So I want you to do the math for that. You do 75 minus 0 divided by 200 times 16 plus 4. So that gives you 10. All right, let's do another example. We're going to look at temperature. Again, we're going to go from degrees Fahrenheit to millivolts. I'm sorry, milliamps. So let's start. Our value B is value A. So our starting point is 73.3 minus our low range. So what is our range? 50 to 300. That gives us our span of 250. So we put 50 up here. 73.3 minus 50 divided by the span, which is 300 minus 50 is 250. We do that math, multiply by 16, and then add 4. So you take 73.3 minus 50 equals 23.3 divided by 250, and then you multiply that by 16, and then you add 4. Gives you 5.49. Let's see if we get that. Yep. So I want you to try that again. Make sure you get the same number because you have to do the mathematical equation in the correct order. Subtract, divide, multiply, and then add 4. Okay? How about 235? I'm sorry, let's go back to this really quick. See, you have to understand here, right? It's 73. On the scale, 73 is much closer to 50 than it is to 300. So it should be a low voltage, right? A low current. So make sure you look at that. It makes sense. How about 235? 235 is very close to 300. So we have to check that one. 235 minus 50 divided by 250 times 16, it's going to be on the high end. And you get 15.8. So I want you to do your math to make sure you get that number again, okay? Because it's important to understand that. All right. Again, 235 is closer to 300 than it is to 50, a lot closer, so the amperage should be higher, okay? Which it is. All right. Now, we're going to do a more complicated problem here, all right? We're going to start with reading a temperature, converting it to what the controller is in milliamps. Then we're going to take what the milliamps coming out of the controller to tell us how much pressure to put on this actuator to regulate the steam valve. All right, so we start off. The value of A is 1406 Fahrenheit, 1406. We take that minus the low range. So the range of the transmitter is 0 to 2000. So that gives you a span of 2000. All right, so it's 1406 minus 0, all divided by 2000. So let's do that. 1406 minus 0 divided by 2000. That is 0.703, and you multiply by 16, okay, gives you 11.2, and then you add 4. So that should be 15.25. That's what I got. All right, make sure you get the math. Now we're going to take another problem. Let's go to the next one. So now we know that 1406 equals this. Now we're going to take 6 milliamps and convert that to pounds. Same exact thing. We're just going to use different numbers. Our value of A is 6, right? 6 milliamps. Now, what's the low range value? Well, it's 4 to 20, so it's 4. And the range again is 16. So we take 6 minus 4 and then divided by 16. And our new range is 3 to 15, so that's 12. Multiply that by 12. Okay, plus we add 3 pounds to that, all right? And that number is 4.5 psi. Okay, so that's where that number ends up. Okay, so this is just a little bit extra math here. Again, if you need to talk to me about it or send me a text, and then your homework will be several of these different problems, and I'll post answers and I'll go over them with you if you want me to do them with you together, and I mean, or separately or one-on-one. That's fine with me, just to make sure you understand it. But again, if you just plug these numbers in and you understand what each of them mean, you should have no trouble, and you're going to be doing this for your project. All right, I'll talk to you later. Have a great rest of the week.